In this video, we are going to be talking about significant digits, accuracy, and precision. So accuracy is the number of significant digits in a number. So the accuracy is how many significant digits there are. So let's take a look at how to count the number of significant digits. And I'm going to start with a silly little story, but hopefully it will help you remember all the significant figure rules. So once upon a time, some friends decided to go to a hot new dance club downtown. So these are all of our friends. And it's called Club Significance. And Club Significance only allows significant members in. So they're all excited, they're dancing around, they're really happy, and they meet this scary looking bouncer, but they thought, we all have ID, we're good, we'll be able to get in. So as they showed their identification, the bouncer nodded and let them pass, and they're all going into the club until these friends were left. And the bouncer gave a growl and said, "You aren't significant fools. The significant club has rules," and wouldn't let them in. So while these friends were all inside the club, dancing around, having a good time, the other friends were at home and really confused as to what happened. I had ID. Why wasn't I allowed in? Why wasn't I considered significant? So the next day at school, they all met back up and they told the story of why they weren't there. So they decided to go to the library to find out what rules the bouncer was talking about. And this is what they found. The first rule was that all non-zero numbers are significant. So any number that is not a zero is automatically considered significant. When a zero is surrounded by non-zero numbers, it is significant. If more than one zero is surrounded by non-zero numbers, they're all significant. When a decimal is in the number, the first non-zero number present and everything after it are significant. And when the number is written in scientific notation, all the numbers to the left of the multiply sign are significant. But what does that mean? So let's break down each of those rules one by one. So the first rule, all non-zero numbers are significant. So this is why all of us that were not a zero got to go in, but the others didn't. Rule number 2 says when a zero is surrounded by non-zero numbers, it is significant. And if more than one is surrounded by non-zero numbers, they are also significant. So if we go in with the zeros in the middle, the zeros will be able to come in. It's like we're sponsoring them or vouching for them. Does it matter how many zeros are in the middle? Nope. It says that even if there's more than one zero, all the zeros that are surrounded are significant. Rule number 3 says when a decimal is in the number, the first non-zero number present and all the numbers after it are significant. So it's like if someone in line has a credit card and says, "I'm paying for myself and everyone behind me." The credit card is the decimal and the guy that is using it is the first non-zero number that appears in the lineup. And the last one, when the number is written in scientific notation, all the numbers to the left of the multiply sign are significant. So again, significant notation is when there's a multiply sign with 10 to the power of something. Okay, so they had the rules down, they're ready to light it up in Club Significance, and they went off and had a great time. So let's look at these questions here. We're going to find the accuracy of the following numbers. And again, accuracy means how many significant digits are there. So I want you to pause the video and count how many significant digits are in each number, and then circle the number that is the most accurate. In other words, the one that has the most number, the highest number of significant digits. Okay, so if we look at this first one, it has 5 because we have a non-zero number in the front and the back. So anything inside is automatically significant. So there's 5 of them. In this one, there's just the 1. These zeros are not considered significant because there's not surrounded by it, it's not scientific notation, and there's no decimal. So just the 3 in this case is significant. In C, all 3 are significant. Even though it's not surrounded, there's a decimal. And remember, that's like our credit card. 2 is saying I'm paying for everybody behind me. So the 0 is considered significant here because of the decimal point. In this one, there's just the 2, because again, yes, we have the credit card, but 5 is holding it. So 5 is the first non-zero number. So just these 2 are considered significant. And same with here, the 1 and everything behind it will be significant. So there's 4. Here I have 4 because it's surrounded. 4. Just these first 3. Just these 2. And with scientific notation, we have these 3 are considered significant. And so this first one here is my most accurate number. It has the highest number of significant digits. Okay, precision is depends on where the smallest significant digit is. So accuracy is the number of significant digits, but precision takes into account where that significant digit is. So for example, both of these numbers, 124,000 and 2.03, both have 3 significant digits. So they have the same amount of accuracy, but they do not use the same powers of 10. So this one would be considered more precise because the 3 is in the smallest place value. So to find precision, you find the power that's the farthest significant digit on the right, and that will tell us the precision. So for example, the accuracy here is 5. There's 5 significant digits. The 7, which is the smallest significant digit, is in the ones place. So its precision is 1, or 10 to the power of 0. For this number, I have 4 significant digits, so it's an accuracy of 4, but the 5 is in the tens place, or 10 to the negative 1, or 0.1, the tens place. So out of these 2 numbers, this number is more accurate, but this number is more precise. Okay, so here are these same numbers again. This time I want you to write the precision of the numbers and then circle the one that is the most precise. So pause the video, start it up again when you're ready. So in this one here, I have 10 to the power of negative 2. 7 is my smallest one, and it's in the hundredths place, or 10 to the negative 2. Here, the 3 was my last significant digit, and it's in the hundreds place, so it's 10 to the power of 2. Here, the 0 is in the 10 to the negative 1's place. In this case, the 6 is in the negative 1, negative 2, negative 3, negative 4's place. Same with this one. This 1 is in the 10 to the negative 1's place. This one is in the 10 to the negative 2's place. In this case, the 5 is the last one, and it's in the 0, 1, 2, 3, or the thousands place. This 2 is in the 10 to the 1s, because remember we have a 10 to the 0, or the 1's place here. This is a 10's place. And this one you have to be really careful because we have this 10 to the power of 4, so you have to write the number out in full to really know. But if you think of it, this 3, if we just look at this number, it's in the negative 2, but then you have to move it 4 places. So it's actually in the 10 to the power of 2's place. And so the numbers that are most precise are these 2, which are tied for the most precise because they have the smallest power. Okay, so again, I want you to reflect on how you did in this video. Give yourself a thumbs down if you're really having trouble solving these problems and you need some help, a pointer if you need some more practice solving these problems, and a thumbs up if you're like, I can do this, I don't need help or any more practice.